Today, we are going to break down the biggest barrier in traditional web development, keyword search. We are entering the era of embeddings and vector databases. But first, what exactly is a vector? If you look at this slide, the technical definition is clear. A vector is a numerical representation of meaning generated by an embedding model. We aren't storing words, we are storing semantic signals in dimensions that we can't read, but the machine can. Look at this graph. Imagine a 3D space where similar concepts orbit together. Here we see how JavaScript, TypeScript, and Node.js are physically grouped together, far away from the banana, apple, and fruit. The distance between them is the difference in their meaning. And what does this look like in code? It looks like this: an array of floating point numbers. Depending on the model like OpenAI, text embedding tree small, we will have vectors of 1536 dimensions. Understanding this is the key to building AI that actually understands what the user is looking for, not just what they type. Okay, we have our vectors, but now we have a logistic problem. Where do we store 1500 dimension arrays to query them in milliseconds? This is where vector databases come in. Forget your traditional databases for a moment. As you can see in the chart, a traditional DB looks for exact matches. If you search for a specific ID or text and it's not there, the query fails. It's binary. A vector database works differently. It is optimized to store and index these high-dimensional embeddings. Instead of looking for equality, it looks for proximity. It uses algorithms like ANN, approximate nearest neighbor, to find the closest neighbors in that semantic space. Essentially, you tell it, give me whatever is most similar to this. To implement this, we have specialized giants like Pinecone, Kudran, or Milebus. But for us, lovers of the JS stack, the start is usually PostgreSQL with pgvector, which allows us to unite our relational data with the power of AI in the same place. Everything we have seen leads us to the ultimate architecture of modern AI engineering, RAG, or Retrieval Augmented Generation. Why is it so important? Because LLMs have two flaws. They hallucinate and they don't know your private data. RAG solves this by retrieving relevant context from your vector database before generating an answer. Look at the diagram. Instead of asking the LLM to invent something, we first consult our knowledge base, the vector DB, and use that information to ground the model in real data. As developers, the logic is very simple. Look at this conceptual snippet. First, we receive the question, how do I configure RAG? Second, we convert it into an embedding using embed query. Third, we search the DB using vector db.search. And here is the key. We inject those relevant docs into the prompt before calling LLM generate. It is just a data pipeline. Now let's build it for real. Look at this. If I search for King of the Jungle using a normal semantic search, I get nothing. Why? Because my database has a lion, not a king. But if I select vector search or AI RAG search, now I can see some results ordered by similarity. Let's look at the code behind this. It all starts at this endpoint, our route. This file acts as a traffic controller. We receive the search params from the user, and here we make the critical decision. It is a simple if-else, but it defines whether we go down the boring string route or if we invoke artificial intelligence. Let's first see why the normal route fails. If we go into query search function, we can see the culprit for why we can't find the king of the jungle. We are using Prisma find many with a contains filter. This limits us to literal string matches. If the user doesn't use the exact word that is in the database, we lose them. To fix this, we need to go to the query AI search function. In the artificial intelligence route, the first step is for the computer to understand what the user is looking for. For that, we call generate embedding. Using the Vercel AI SDK, this is trivial. We pass the test king of the jungle to the test embedding tree large model. This transforms the phrase into that mathematical array of numbers we saw at the beginning. Now, we no longer have words. We have coordinates of meaning. We can also see the usage or the cost that it generates. With that vector in hand, now we can ask the database. Here, we drop down to raw SQL with query raw. to leverage the power of pgvector. Look at this key line. This operator measures the distance. By subtracting it from 1, we get the similarity. And notice the pro trick. We do a hybrid search. We use OR, we look for text matches, or vector similarity. This way, we capture the best of both worlds, the precision of keywords and the intelligence of context. Let's go back to the UI to see the full cycle. When sending King of the Jungle, the endpoint chose the AI route, generated the vector, and Postgres found that the lion vector was mathematically closed. The system understood the intention behind the search. This is what differentiates a modern app from an app from the last decade. You are probably wondering, how did the animal vectors get into the database in the first place? We do that with a CDN script. Before launching the app, we iterate through all our data and generate embeddings for the titles and descriptions. It's a process that runs only once. Without this ingestion step, your database will be semantically blind. One final warning for production. Comparing vectors one by one, as we did here, is slow if you have millions of data points. To scale, you need to create an HNSW index in Postgres. This turns the search into something instant, allowing your app to fly even with millions of records. If you are going to charge for this, don't forget the index. Hey, let's try another searches. Nemo animal movie. Okay, it's not in normal search, but if I select AI rack search, okay, I get the clownfish. One more. Big animal. Okay. And the last one, best human friend. The dog. Implementing artificial intelligence doesn't have to be black magic. Today, you demonstrated that using tools you already master like Next.js and SQL, you can build world-class search systems. Remember to like this video and subscribe to the channel. I'll see you in the next video.